All right, so now we're moving on to our new material, the last topic of this chapter, this semester, inclines. So we have friction force, and now we're going to add an incline. So instead of right or left or up and down, we have this on a slant. It's going down an incline. Okay, so this is the surface, this incline. The normal force is going to be an object sliding down an incline has three forces acting on it: the normal force, gravity, and the frictional force. So the normal force is always perpendicular to the surface. Remember, that's our definition of normal force. It's perpendicular to the surface. Friction force is parallel to the surface. And it's the opposite direction of the motion. The motion's going down this way. So friction force is going to go up this way. Gravity force points straight down. So this is the box. It points straight down. So that's the weight of the box, straight down. So for these problems, it's going to be easier to shift the coordinate, XY coordinate system so that the x-axis points along the incline and the y-axis is perpendicular to it. Okay, so we're going to shift this coordinate axis system so that this x-axis now is parallel to the incline and the y-axis is perpendicular to the surface of the incline. Okay. Now that means we need to find the x and y components of the gravity force of gravity, so that it's along the new y and x axis. Okay, and so the new axis up, this is positive y, and going down the incline is positive x. All right. So if this is theta, and this is a right angle, then this means this is 90 minus theta, right? So if this is 5 degrees, then this would be 85 degrees. The angles of a triangle all have to equal to 180, all right? If this is 90 minus theta, then this right angle, for this right angle, that means this has to be equal to theta. Okay, so for example, if this is 85 degrees, then this must be 5 degrees. Okay, so now we have our angle. Let's find force of gravity in the x direction and the y direction. This is our original vector. Okay, so this is theta. So what is that? This is the y-axis, and this is the x-axis. Okay, so what trig function would the y-axis or the y component of the force of gravity be? This is theta, so this is adjacent. So this vector is FG cosine theta. And is it positive or negative? It's negative. This is positive, and this is the negative direction. So it's supposed to be a negative here. Okay, and then this one is sine. So this is theta, so this is opposite. Gives you the x direction. So FGX is force of gravity times sine of theta. Opposite, it's the opposite vector, opposite from the angle. So FGX is FG sine theta, FGY equals negative FG cosine theta. Okay, so a skier descends down a 30 degrees slope. The coefficient of kinetic friction is 0.1. What is her acceleration? So all the problems should be similar. Shouldn't be any surprises here. So what is her acceleration? Okay, so your acceleration is in the x direction. It's going down the incline. So we are given kinetic friction, and we know that, we are given the coefficient of kinetic friction, 0.1. So we know we do need to find normal force to find this friction force. So when you're given coefficient of kinetic friction, there's a good chance you're going to need to find that normal force. So let's find that normal force in the y direction. Sum of the forces in the y direction equals to mass times acceleration in the y direction. Is the skier moving up and down this y-axis? No, it's just going down this incline. So acceleration in the y direction equal to 0. Okay, so we have force normal minus force of gravity in the y direction. And we found that that was Fg cosine theta. Okay, so force normal minus Fg cosine theta. Is there any other forces in the y direction? No. Okay, so that equals to 0. Add this term over to the right side. So force normal equals to mass. Again, remember, force of gravity for the skier is the weight. Mass times acceleration of gravity. Okay, so this is the weight of the object here. Okay, so Fg, force of gravity on the object, is mass times acceleration of gravity times cosine 30 degrees. 30 is given, 30 degrees is given. Okay, so that's equation 1. Okay. Now I want to find acceleration. Okay, so we found the y direction. Now let's go to the x direction and see what we can find there. Sum of the forces in the x direction equals to mass times acceleration in the x direction. So we have this, what do we have? This is the x-axis now. So we have this Fgx, so the x component of the force of gravity on the object, that's Fg sine theta, positive. It's going on the positive x-axis to the downward on the incline. Okay, so Fg sine theta minus, this is going up the incline, minus friction force equals to mass times acceleration in the x direction. Is there acceleration in the x direction? Yes, the skier is going down the incline. This is the x direction. So yes, there is acceleration in the x direction. Okay, so plug in all the numbers that you know. Mass times acceleration of gravity, sine of 30 degrees, minus mu k times normal force. Remember, kinetic friction force is mu k times normal force. We know mu k is 0.1. Okay, times normal force equals to mass times acceleration in the x direction. Okay, so this is our second equation that we know. Okay, mass times acceleration of gravity times sine of 30 degrees minus 0.1, coefficient of kinetic friction, times normal force equals to mass times acceleration of acceleration of the skier. Okay, this is acceleration of the skier. Okay. So we don't know acceleration and normal force and mass. But here, when we plug in one equation into the other, we're going to see that the masses are all going to cancel out. So let's plug in equation 1 into 2. So we're going to plug this normal force into this here, into equation 2 here. Okay, so that's mass times acceleration of gravity times sine of 30 degrees minus 0.1 times normal force, which we get from equation 1 here. Mass times acceleration of gravity times cosine 30 degrees equals to mass times acceleration of the skier down the incline. Okay, we see that all these masses cancel out. So if I don't give you mass, or then there's a good chance that they cancel out when you plug in one equation into the other. All right, so 9.8 sine 30 degrees minus 0.1 times 9.8 times cosine 30 degrees equals to acceleration, which equals to 4.05 meters per second squared. Okay, let's see, everything's given in 2 sig figs. So 4.1 meters per second squared is your final answer.